Hi, welcome to Light Utilage. In this session, I will discuss how to find limiting reactant in a chemical reaction by another method. This is a problem given over here, and it states that in a chemical reaction, 24.5 gram of aluminum reacts with 56.2 gram chlorine gas to produce aluminum chloride. The question asks to find the limiting reactant in the reaction. In these problems, we always write the balanced chemical equation at first. Let's write the balanced chemical equation. Aluminum is the first reactant and its symbol is Al. It reacts with chlorine gas. Its symbol is Cl2. And they produce aluminum chloride. Let's write the formula of aluminum chloride. Aluminum has +3 charge and chloride ion has -1 charge. And before we combine these ions, we balance their charges, we crisscross their numbers, we get the formula aluminum chloride, that is AlCl3. This is the product formed in the reaction. This is a chemical reaction taking place. Now we balance this chemical equation. On the right side we have a 3 Cl atom, on the left side we have 2 Cl atom. To balance a Cl atom, we switch their numbers. I put here 3 and I put here 2. Now the number of Cl atoms are balanced. Now we balance the number of aluminum atoms. On the right side we have 2 aluminum atoms. On the left side we have 1 aluminum atom. That's why I put 2 before. Aluminum atoms. Now the number of aluminum atoms are balanced. This is a balanced chemical equation. Well, the mass of these reactants is given in the problem. The mass of aluminum is 24.5 gram. I mentioned here 24.5 gram. And the mass of another reactant, that is chlorine gas, it is 56.2 gram. 56.2 gram. The question asks to find the limiting reactant. Limiting reactant is the reactant which produces less amount of product in the reaction. By using the mass of these reactants one by one, we calculate the mass of aluminum chloride produced in the reaction. Then we can compare the mass of this product. Let's begin with the mass of aluminum. Well, the mass of aluminum is, here we have 24.5 gram. 24.5 gram aluminum. We convert the mass of aluminum into moles, and when we convert mass into moles, we always use molar mass. Well, the molar mass of aluminum is 27.0 gram. Well, it means that 1 mole aluminum has 27.0 gram aluminum. Here I mention 1 mole aluminum, and so here we mention 27.0 gram aluminum. We arrange molar mass in such a way so that we could cancel gram aluminum. Now here we got the moles of aluminum. Now we convert the moles of aluminum into the moles of product, that is aluminum chloride. For this purpose we use the mole ratio. This is where we need the balanced chemical equation. In the equation you can see that 2 moles of aluminum produce 2 moles of aluminum chloride. So the mole ratio is 2:2. Here I mention 2 mole aluminum chloride is produced by 2 mole aluminum. Here we got the moles of aluminum chloride. In the next step, we convert the moles of aluminum chloride into mass by using molar mass. Well, the molar mass of aluminum chloride is 133 gram per mole. I mention here 133 gram aluminum chloride, and in the bottom we have 1 mole aluminum chloride. Now we can cancel. Here we have gram aluminum, mole aluminum, and mole aluminum chloride, mole aluminum chloride. Here we have 2 at the top and 2 at the bottom. We can also cancel the same numbers. Now we can do the calculation by using the calculators. In the top we have 24.5, and so that is multiplied by 133. We use the calculators. In the top we have 24.5 and it is multiplied by 133 and the value which we get, that is 3258.5, and in the bottom we have 27.0, and the next number is, that is 1, where we get the same numbers. That's we divide this number by 27.0. We divide this value by 27.0, and this is the value we get. Well, we pick up this value with least significant figures. We look at the mass of the reactants, and if we look at the mass of reactants, you can see that the mass of each reactant is given with 3 significant figures, 1, 2, 3. That's why we pick up this value with 3 significant figures, 1, 2, 3 up to decimal point. We have 3 significant figures, and so if we look at the next digit, that is 6. 6 is greater than 5. That's why we round up 0 to 1. The value which we get, that is 121. I mentioned here 121 gram, and so here we have aluminum chloride. This is the mass of aluminum chloride produced by 24.5 gram of aluminum in the reaction. In a similar way, we calculate the mass of aluminum chloride produced by 56.2 gram chlorine gas. Now let's begin with the mass of chlorine. Well, here we have the mass of chlorine gas, that is 56.2 gram. I mentioned here 56.2 gram chlorine gas. Well, we convert the mass of chlorine gas into moles. We use the molar mass of chlorine gas. Well, the molar mass of chlorine gas is 70.9 gram per mole. I mentioned here 1 mole chlorine, and so it is 70.9 gram Cl2. We got the moles of chlorine gas. Now we use the mole ratio to find the moles of aluminum chloride. We look at the mole ratio between chlorine gas and aluminum chloride in the balanced chemical equation. In the equation, you can see that 3 moles of chlorine gas produce 2 moles of aluminum chloride. So the mole ratio is 3:2. Since we are going to calculate the moles of aluminum chloride, we put the moles of aluminum chloride at the top. I mentioned here 2 moles aluminum chloride, and at the bottom we have 3 moles chlorine gas. In the next step, we convert the moles of aluminum chloride into mass. For this purpose, for this step, we use the molar mass of aluminum chloride. We have already mentioned the molar mass of aluminum chloride, that is 133. Here I mentioned 133 gram aluminum chloride, and in the bottom we have 1 mole aluminum chloride. Gram Cl2 will cancel, mole Cl2 will also cancel, and here we have mole aluminum chloride also get cancelled. We can do the calculation. Top numbers are divided by bottom one. We multiply the top numbers. In the top we have 56.2, and it is multiplied by 2, and again we have another number, that is 133. This is the number we get, 14,949.2. I mentioned here 14,949.2, and in the bottom we have 70.9 is multiplied by 3. We use 70.9 is multiplied by 3, and the value we get is 212.7. Here we have 212.7. We divide these numbers. In the top we have 14,949.2, and it is divided by 212.7. This is the value we get. But we have to write this value with 3 significant figures. 1, 2, 3 up to 2. We have 3 significant figures. So we look at the digit next to 2, that is 8, and 8 is greater than 5. That's why we round up to 3. The value we get 70.3. Here we have 70.3. This is the mass of aluminum chloride produced by the mass of chlorine gas. Now we can compare the mass of aluminum chloride produced by both reactants. Here we have 121 gram and here we have 70.3 gram aluminum chloride. Here you can see that 70.3 is smaller than 121. Here since chlorine gas is producing less amount of aluminum chloride, that's why chlorine gas is a limiting reactant in the reaction. This is how we find the limiting reactant by using this step. Thank you.